tout le monde. Ça va aujourd'hui? Bon anniversaire à DevOps Genève, non? 5 ans. I'm going to switch to English because my talk is in English, so sorry about that. I wanted to, go in French, but that's it. So my name is Diana Todea. I'm an SRE at Elastic, and today I'm going to be speaking about root cause analysis, so diving through RCAs, a quest for reliability. So, yeah. So, like I said, I'm an SRE, but I'm focused on observability. You can check my GitHub repo where I already added the presentation that I'm doing right now, so you can have a minute if you're online and go and download the slides. You can check, we can connect on LinkedIn. If you have questions for later, just let me know. So how many of you in today are working or have worked as SREs or DevOps engineers? Cool. And how many of you have ever been on call and have stressed about incidents and, alerts and so on? Many of you. Perfect. So today I'm going to be speaking exactly about this situation, about how we are behaving during, let's say, on-call when we have like a severity 1, severity 2 incident, how we are like in this situation where we have alerts on one side, managers on the other side asking for updates, and then we have like, customers that, well, what's happening with my deployment, what's happening with my application. And we are in a constant pressure, basically wanting to, give the best of ourselves, but we are also panicking in the same way. So we can totally relate about the same situation. I've been there, I've been on call, and it's part of our jobs. And the one thing we want to take from this situation is that how we can, become better, how we can improve. Every time we have an incident, how we can improve. And how also we can apply a solution successfully and, let's say, perhaps even sooner than it should have happened. So what is basically a root cause analysis? I'm pretty sure you have heard about this term before. Do you normally use post-mortem analysis in your companies after an incident? Perfect. So yeah, that's normal. That's how it should be. So a root cause analysis is basically like a scientific method. Well, it is a scientific method. It works also like in engineering, but also like in different sciences. So it's a process, actually, of discovering the root causes of problems in order to identify appropriate solutions. So it's like that quest, that quest to put your finger on the right root cause and then grab the appropriate solution. Also, it's very good that normally when we do such a root cause analysis, we aim at 4 main steps. So we try to identify and describe the problem. Then we establish a timeline that, normally we have all in the incident channel or in the incident management platform, you have like all the timeline that when it happened, until it's solved. And we're trying to distinguish between a myriad of root causes, right? And not least, after we solve the situation, we are trying to prescribe the corrective actions to prevent the reoccurrence. So it's very important to have like a post-mortem analysis, root cause analysis, every time we have incidents, right? Because it will help us later on, normally in everyday life. So the post-mortem culture actually is not a new concept. It's something that Google has coined some years ago. And it's trying actually to shift the focus from negative, let's say, terms like mistakes, errors, blame, that normally cause stress and, is not very good for reliability in general and productivity, and shift it to something like more positive. So how we can collaborate, how we can have that open communication, how we can, achieve everything and do this within the post-mortem reviews process, like we talked about. So it's very important to focus on having the right attitude, the positive outlook, so we can, improve our system, basically. So I want to take here, pause and take like some use cases from Elastic. Actually, you know, wanted to give this talk. I actually wanted to relate with the SREs and DevOps engineers like yourselves. I wanted to focus like, hey, but what's happening at Elastic? So if I'm doing like an analysis on, let's say, severity 1 and severity 2 incidents at Elastic, I discovered something really interesting. So I discovered that, for instance, like top 3 root causes of such incidents focus on 1, upgrades. That could be, you know, system upgrades, software upgrades, coming from the external world, like, you know, let's say, for example, Linux kernel being updated, or, I don't know, a bug in GDK, or, I don't know, let's say a cloud provider tries to upgrade something and then forgets to communicate with the rest of the stakeholders, as well as, you know, from internal world, so from the internal organization. That's like what happens normally. Then the second root cause would be focused on network. So if you change like one thing in a network, then you have like a cascading effect in your organization. And it can impact, obviously, also your customers and so on. If you change, like, for example, a proxy, then, you know, something definitely can cause some issues in production at some point. And third but not least, security. So as yearly, you know, like security issues appear, new attacks appear, is something that, you know, it's kind of like became part of the normal tradition to have this on the top 3 causes. Right, so today I also want to give an example, just to make it like, you know, put some flesh on the theory. And I want to give an example of such an incident that happened at Elastic a while back. That was actually this, like a normal upgrade that, you know, shouldn't have triggered anything problematic, a live Linux kernel patch. You know, the incident happened and nobody actually you know, focused and understood that you know, the incident was actually ongoing, because, you know, it was something normal. It was like a normal maintenance, a normal procedure happening, the on-call engineer, you know, observing some errors, some alerts, so nothing unusual about that. So describing a bit the context here is like, this incident actually caused the downtime of an entire region. It didn't last so long, if you want to take it more or less. So it lasted around 7 hours. Sorry, 5 hours, but the impact actually was around 7 hours. And affected customer deployments, as you can see, over 1,000, and affected the organization around 750. So this happened, you know, it was like quite a big incident. It could have been worse. And here, like, besides the technical points, so I wanted to point out how the cascading effect actually occurred. So it happened like from a normal, let's say like a normal procedure, doing a live Linux kernel patch, then it affected the network functionality on allocators, and then at its turn, impacted the internode communication for deployments. From here, I wanted to basically point out a couple of things. Mainly that the on-call engineer normally has normally a hard time understanding like where the issue comes from. Normally, in order to understand the severity of an incident, somebody else or another team, or most likely customers, will have to draw the attention on the severity of that problem. So until to understand that, okay, it's not a severity 3, it's not a severity 4, it's not a severity 2, some hours have passed in the meantime, and you know, then it was escalated and identified properly. Then also, like in situations like this, an engineer on call is trying to dissociate or is trying to identify several root causes, and that is quite difficult. Like, we know we deal with so many technologies, with so many, I don't know, deployments, machines, and sometimes you think like, okay, do I need to restart this? Do I need to, I don't know, upgrade something in the network? What should I do? So these steps actually take time, and it's basically part of human nature sometimes, you know, that we are coming like from this, the part where we are confused and trying to focus a bit more on something more, let's say, focused. So in this case, what I wanted to show you with this example is that part of the post-mortem analysis or the root cause analysis we performed afterwards was that we understood that we needed to improve a lot of things. So we needed to focus more on observability. And here I wanted to point out the 5 whys methodology. Probably used it in your company as well. One of the, let's say, methods of getting to that root cause is asking the 5 whys. Why this happens? So why is, I don't know, this deployments have started to malfunction? Why this network has started to malfunction as well? So you always ask like a number of whys until you reach the actual root cause that is for your issue. So based on these post-mortem reviews, normally we always face like 2 types of attitudes. One is like the reactive management. That is like, the normal reaction that we have, when we see incidents happening. But we want to focus on something that is better than that. We want to focus on the proactive management. That is the idea when you actually apply and you improve your tools and you gather feedback and information and you want to prevent those incidents from happening again. And in my opinion, the best way to achieve this is through observability. So it's through the observability tools, improving them and actually making use of them in everyday life. So this is what happened at Elastic. We started step by step to do these changes, to improve, to put a more focus on observability. And we implemented a series of changes that I'm going to describe right now. So we actually moved from third-party tools. So I don't know how many third-party tools are using in your organization, but the problem is that you always have to go to another point to manage them, right? So it's not something internal, it's not something that you own. You have to, I don't know, either speak with another team, either go to a third party that manages that specific tool, right? So it's good to get rid of that and focus on something internal. In this case, for example, I'm going to give the example that we used in the past Statuscake. It's a monitoring tool, alerting monitoring tool, and we got rid of that and focused on Kibana internal alerting tool, which gave us the possibility to manage it as well. Then we created uptime checks, synthetic monitoring. So I'm not sure if you're familiar with the concept of synthetic monitoring, but that is basically like doing checks on your applications, on your system that will give you the information of how the system reacts before actually the interaction, the real interaction with the users. So it's a proactive method to test your system, test your applications. Then we created SLOs, which are service level objectives, and burn rate alerts, all this in the observability stack. And we integrated as much as possible with the Elastic Observability AI Assistant. So to put some, let's say, images on this theory, I wanted to show you like in the observability stack in the Elasticsearch, you can view here like the Kibana alerting part that is focused on a myriad of types of rules. So you can create different types of rules that are focused on specific use cases. And you can have it like serverless or different, you can match it with different data views that you want to use. Also, this is the synthetic monitoring I was telling you about. In this case, they are basically monitors that check the status of deployments. Obviously, if it's green, it's good. If it's red, it's bad. So that's like a proactive measure to say like, okay, there's something wrong with the deployment. Like it might be a networking issue, it might be the whole deployment going down, but it's also like another layer that will help identify what's the status of your system. And then the SLOs that I said, which can be matched with different services that you use. Right, so this is like, let's say, a bit of a user interface definition. Right now I'm going to show you a demo because it's good to have something to start with a demo. So this is an open telemetry application integrated in the observability stack. Here I'm showing you the SLOs that we have built for this application. So that is the proactive part that I was telling you about. You can see whether they have been violated or not. You can check directly inside the application, like what's the status of the application, if you have any failed transaction rates, any errors, metrics, logs, etc. So you can have here in the application performance management tab all the information that you need, the metadata. So basically a lot of useful information, while either if you are in an incident or preferably not in an incident, and you can also check directly. You can also integrate it directly with Elastic AI Assistant, right? So Elastic AI Assistant is trained with that specific information that we have provided. In this case, what I'm showing in the demo, it has been trained with information on documentation, runbooks, and GitHub issues. So I'm asking, what is the possible cause for this error? And will give me a network issue, server issue, configuration errors, etc. So connectivity. Is my application, is my application experience connected with the runbook? In that case, yes, it is connected with the runbook. I will do this. The Elastic AI Assistant will give some information on the runbook, and it also gives a link for the GitHub issue. So it's very easy to handle in case of any troubleshooting. So it'll give me the GitHub issue, and I could click directly on it, open up directly GitHub, and show me the runbook I have defined. So this is like what's normally the workflow that we have during troubleshooting, preferably during an incident or before, that doesn't matter. So it's actually an assistant that helps us, like SRE and DevOps engineer with the normal daily ops. Right, so this part was focused on observability, but we also can focus on something like infrastructure. The previous incident I showed you was something like, something quite important, but also lots of incidents are focused mainly on infrastructure. So let's say, I don't know, deployments going down, machines that are having some connectivity issues. So many, let's say, smaller severity incidents are caused by infrastructure. In this case, we focused on cleaning up the bill, focus more on reducing the number of allocators, also upgrading the family instances. So we did a lot of work within the infrastructure, which actually reduced the number of incidents by half or so in 1 year. Next, we focused on documentation. It's very important, like you all know, to update that documentation, the runbooks, write new processes, get involved with the community. So that means, like, in case you are there on a forum or you want to ask something from the customers, you can do that via the community. It's really important that sometimes you get some use cases that you have never seen before. And also you get a feedback on the products that you are using. Sometimes when you're using your products internally, you use it in a different way. And the customers, the community, let's say not only the customers, the community itself can help you immensely with a very valuable feedback. And then we focused also on the incident management platform. We tried to automate as much as possible in the incident management platform so we can reduce the time of the incident severity, on identifying the incident severity. Like I said in the example above, we lost some significant time in identifying the correct severity on that incident. Well, right now this is automated directly in the incident management platform. Also, we integrated runbooks, documentation with the same platform. So basically, we try to liberate and for the engineer to have more time to actually fix the issue. And not least, all these smaller, or let's say segmental, like fragmented changes lead to bigger changes, like changes in system design, changes that come from hours and hours of engineering work. And these changes are, throughout the span of months, even years. Here I just wanted to point out a few examples of a few use cases that can also be very relevant for your organization. In this case, such post-mortem reviews and root cause analysis on incidents drove us to understand the importance of cost optimization. One change was transition to serverless. So since last year, Elastic has been transitioning to serverless, adopting Kubernetes in production. So doing that, trying to focus more on the latency, on reducing the latency of queries and decoupling the storage. Next was introducing the Elasticsearch query language, thus expanding, optimizing even more the power of queries. And not the least, what I showed you before, also with the OpenTelemetry application, is giving back to the community. Is that communication with the community, that open collaboration that I showed previously. So since last year, Elastic has been donating a few bits to OpenTelemetry community. So that means it has started with Elastic Common Schema. Nowadays, in 2024, has donated the BPF-based profiling agent to OpenTelemetry community. So that means like an ongoing collaboration with the open source community. And not the least, like you've seen in the demo, the observability AI assistant. Not the least, I wanted to focus more on the human factor. So we are all people. We are all in that, let's say, SRE world, in that incident moment when things happen and we don't know how to react. It's very important to take a moment and observe, not only via the tools that we have, but actually decide and understand like the behavior of the applications, the behavior of our systems, and have more confidence in ourselves, right? Because we spend a lot of time, we actually spend a lot of time in trying to take the right decision, in trying to decide and react. Those hours actually amount to money, amount to like, I don't know how many deployments being, lost to customers. So it's very important here to have a bit more confidence, upskill, right, train, observe, understand why the systems are behaving like this, and act proactively. So act and take the right decision and don't waste time. This is what, let's say, like one of the conclusions I wanted to share with you, because besides the tools that we are operating with, we are one big factor, decisive factor when dealing with, with incidents. You can go ahead and view some of the resources I shared with you that can go a bit more in depth with the pieces I described so far. And yeah, thank you very much for your attention. Merci beaucoup pour votre attention. If you have any questions, you can also leave a feedback via the QR code there. And I think we have plenty of time for questions.